हेलो गुड मॉर्निंग एवरीबॉडी। एक बात बताओ, सर क्या यहीं पे बैठे रहेंगे क्या? अभी क्लास शुरू हुई नहीं है, सर कहाँ से आएंगे? 10:02 हुए हैं। और बताओ, हाउ आर यू, हाउ इज एवरीबॉडी? सेटअप रेडी? मेरी आवाज क्लियर आ रही है? आई एम एब्सोल्युटली ऑडिबल एंड विजिबल। चमका हुआ हूं मैं, नहाया हुआ है ना। हेलो बेटा, हाउ आर यू? गुड मॉर्निंग एवरीबॉडी। गुड मॉर्निंग। ओके, still it is 4 waiting. I don't know why it is 4 waiting. Yes, 11 watching. Top chat, it is live chat. So this is the batch which is going to start from 16th of August, and it's going to be an absolutely fabulous batch. So anybody who wants to join this particular batch, go ahead and join it now. I believe today is the last date for this particular discount. Botany, chemistry, zoology, and very soon physics also will be joined in this particular batch. It's the Elixir Dropper batch. You can get the subscription using the code WS Live, and you can even use the code AV Live. So go ahead and use the code AV Live or WS Live as you like. So Elixir Dropper Batch, this is the line phone number which you can use to understand this. That's me. And Ananya, are you there? You had to ask some question. What is approved? ये क्या कर रहे हो भाई? Naruto Uzumaki and Tirthraj Mukherjee, you have become the chaddi buddy like that. आज स्पेशल में पंखुड़ी मैम एंड आपका सॉलिड स्टेट वाला क्लास सेम टाइम में है। कहाँ है आज? ये कौन सी क्लास के बारे में बात कर रहे हो अनन्या? Which class are you talking about? What same time? Evening, I don't have a solid state class. Solid state class is right now. और क्या करें बेटा? क्लासेस तो क्लैश होंगी ही होंगी, कहीं ना कहीं तो होंगी. We can't help it. So many classes, and every educator wants to give the entire knowledge to you. Special class, what time is there? स्वाति मैम की स्पेशल क्लास कितने बजे है? She took a special class in the morning as well at 9 o'clock. What time is she having the class? अरे टाइम तो बोलो यार, टाइम. क्विज सेशन, क्विज सेशन. टाइम 8 बजे है ना, तो मैंने 8 बजे क्लास रखी कहाँ है? वेयर इज द क्लास टुडे? एंड कांट हेल्प इट बेटा, ये तो होगा ही होगा. कुछ ना कुछ तो क्लैश होना ही होना है. एंड टुडे इज द 31st. सो वो कहता है मंथ एंड है. ओके नाउ. हाँ, अनन्या, you had a problem about the face centered and the end centered. Excuse me. Now I'll tell you one very simple thing, very simple thing. When you talk about the face center and the end center, first of all, the thing is they are the same. Yeah, what happened? Okay. तो मैंने 8 बजे तो अभी तक क्लास रखी नहीं है ना. अभी कहाँ रखी है? Don't worry. Today we have the class at 4 p.m. and there we are going to do the metallurgy part. So today we are going to have the part of metallurgy, and hopefully we are going to finish off metallurgy today. Is it clear? Is this clear? Now, Ananya, and we have a group, a WhatsApp group where you can inform me and you can tell me. So you can just simply give the entire information on the WhatsApp group. We are going to interact on that particular group, and we can even have a group call on that particular group. You know that we can have a WhatsApp group call. Okay. So we are going to interact, and this is going to be a personal batch. It is going to be a one-to-one batch, and I'll make very sure that you get maximum marks. And please, जो बोल रहा हूं वो करते चले जाओ. ठीक है. अगर आप करते चले जाओगे तो it will be nice for me, it will be nice for you, you will be getting very good marks in chemistry. But understand that there are certain restriction in the online batch, and that restriction is मैं आपका कान पकड़ के नहीं घुमा सकता, और कोई restriction नहीं है. ठीक है. तो तुम कहोगे भगवान का शुक्र है कान पकड़ के नहीं घूम रहे. ठीक है. और मेरी बहुत गंदी आदत है, आई जस्ट आस्क यू कि कान पकड़ के फोटो भेज दो. समझे? Yes, Poonam, we want 180 on 180, and there are 6 people watching at this moment. क्या कर सकते हैं? चलो, let's talk about the face-centered and the end-centered group. Now, let us say we have a cube. Okay, this is a big cube. Okay, now if I place a particle in its face center. Now, this is a particle in the one face center. This is the particle in another face center. This is the particle in the next face center. This is the particle in another face center. This is the particle in another face center. Okay. And this is one face center. So here we have the 6 face centers. Clear? Now, this is the face centered cube here. In text question, Beta Ananya, we are just going to look through the NCERT, and then we are going to talk about the in-text question. And I believe you all have got the NCERT solid state chapter in your Telegram channel and in your WhatsApp group. I have already sent the PDF of the uh, this group. Clear? And are you attending that particular website that I have asked you to attend? Are you attempting the question there? I hope you don't have any lack of questions now. And I should see the viewers. Now, this is what we have as the face-centered cube, because in all faces we have the system. Okay. Archana Verma has never joined. Dr. Vivek has not joined. I will eliminate those people. Kushi Hazari, no. Titraj, you have joined in 19 hours before, and Ritik has joined 4 days ago. Priyanshu has joined at 2 days, 3 days. Prerna has joined out before 2 days and she has not joined again. Piyush, 4 days. Jitender, 5 days. Chandan Kumar, 13 hours. Ananya Sarkar, you joined 4 days ago. Poonam Singh, you have not joined this particular batch. Have you joined the WhatsApp group? Akshay Thakur, you have not joined it. Gariyash, Sarthak, Naruto, you have not joined it. Okay, fine. Now, if I just remove the spheres from all the four positions, and I have the sphere only in two position. That is the opposing faces. And remember, these are alternate faces as well. This. Now this becomes end-centered. Anina, is it clear now? हाँ तीर्थराज, आपने 19 घंटे पहले ज्वाइन किया था। आज 4 PM पे क्लास होगी, किसने कहा नहीं होगी? हु सेड दैट कि नहीं है आज क्लास? भाई नारुतो उजुमाकी को लिंक भेजो, ज्वाइन दिस। Okay then, let's get along with the NCERT of solid state. Everybody has opened up their NCERT books, whether it be on digital mode or it be on this mode. So, fluids. I gave you the definition of fluids. Just read through it. The first part. Naruto, you have got what you need to join. Okay, Subrata, what do you mean by yes, sir, the book? Those who have not liked the session, go ahead and like it. Read through it. This is all we have already done. And yesterday I also provided you with the notes of solid state. So you have more than enough material. You don't have any problem of material and you don't need to run around looking for the materials. Now this part would be right. Anyone has to ask anything in whatever is written here? Now these are the important parts. In the solid state chapter, we have not only read through the chapter, we have not only understood the chapter, we have already done the NCERT as well. Are you reading through it? Crystalline and amorphous. How graphite is not an exception? Why should graphite be an exception? Tell me what is exceptional about graphite. Tell me what is exceptional about graphite. बताओ अनन्या, ग्रेफाइट में एक्सेप्शनल क्या है? Graphite is a three-dimensional solid. Okay, it has layered structure. Okay, graphite is a three-dimensional solid having a layered structure. Anything clear? Anything problem with that? And then graphite has an unshared electron. That electron forms a electron cloud over its surface and below its surface. Fine. What's exception about it? It is hard. Okay, I'll show you graphite. I have graphite with me. I'll show it to you. Where are my big kits? Graphite is identical to a rock. I'll just don't have. Exception in conductivity. Beta, then there's so many exceptions. Silicon. Silicon is a semiconductor. Boron. Boron is a semiconductor. Okay. Then we have chromium oxide. That becomes a conductor. It has a metallic conductance. So there are so many things. Silica, SiO2. That has a piezoelectric property. So if NCERT mentions it to be an exception, that doesn't make it an exception. And why should I say it to be an exception? Who says that the conductors, the covalent networks compound cannot be conductors? Why it should not be? Okay. If we have 10 covalent network solids and out of that one becomes a conductor, 10% is not an exception. Exception means it has to be rare. It is something like 0.01%. But if it is 10%, that is not an exception. Why do we have to mention the conduction at all? Is that clear? Okay, now just read through it. But if NCERT says it's an exception and you want to say it is an exception, I have absolutely no problem. पूनम सिंह, आपने एनसीईआरटी के क्वेश्चन कंप्लीट कर लिए? पहले तो सवाल ये है. I am not saying you have to do questions only from NCERT. What I am saying is, before you do any other question, do the questions from NCERT. That's what I am saying. I never said only from NCERT. हाँ आज डिफेक्ट्स भी करवा दूंगा. Are you reading through it? I've told you that they have sharp melting point. Anyone has any kind of doubts? Read through it. Read through it. And anybody who has not liked the session as yet, go ahead and like it. We have done all these. Any part, any confusions in this part? Any problems with these in-text questions? Ankan, welcome back. Where were you for the so time? Isotropic and anisotropic, why don't you see the session? I told very clearly that isotropic are those in which we have the same arrangement in every direction, and that simply translates to amorphous substances. Bheed, irregular arrangement. Since there is no regularity in any direction, that means all direction it is equally irregular and identical arrangement. Is that okay? So electrical resistance show different values in crystal. Yes, electrical resistance show different values in crystal according to direction, something like graphite. If you have graphite and you have it layered, graphite is a layer-like structure. If you put electrical potential here, it is going to be a good conductor. But if you put electrical conduction here, here it is going to become an insulator. Because the electrons cannot move from one layer to another layer. They can move within the layer, but they cannot move from one layer to another layer. And that is how the graphite becomes an insulator according to the direction. Prasad. Prasad has asked, Ritik. Ritik, you have asked me, sir, only use pure English. Yes, I am using English. What's the problem in it? Is it clear? Uncle, you need to join the Telegram batch also. Did you not join the Telegram group? So, Ritik, what exactly is the problem? Ritik, I have just got a message from Prasad. Is that not your account? In Telegram, somebody has said, Prasad, that use only English. "9:53 a.m., July 31st. 13 part 2. Why are solids rigid? Because the attractive forces don't allow the particles to move. That is why they are not flexible. Okay. And then which question are we talking about? 1.32 or which one? 13 part 2. There isn't any question of that kind. Yes, Ritik, we are going to have regular session in the morning. In text question, which one? 1.3. Classify them as the solid, amorphous, or crystalline solid. So polyurethane, it is amorphous. Naphthalene is crystalline. Benzoic acid is crystalline. Teflon is amorphous. The polymers are amorphous. Potassium nitrate is crystalline ionic solid. Cellophane is amorphous. Polyvinyl chloride is amorphous. Fiberglass is amorphous, and copper is can be considered it's polycrystalline. So it can be considered as crystalline. Is that clear? But there isn't any 13th question. There is 1.3. This is 1.3. Is this clear? Now, which one? There isn't any 13th question. Polar Piyush does not mean charged. Polar means that is having a dipole moment. That is, we have a molecule, this is this. This is a molecule, then there is a delta positive charge here and delta negative charge here. Something like HCl, something like SO2, something like H2O. These are polar molecules. Is it okay? So that is what we have as the polar molecules. It's a 1.13. 1.13 is far away. Where is 1.13? Anna, which page number? Okay, here. 1.12 is here. Now it's going to be 1.13. Where is it? Here. Ananya, this question are you talking about? Safan Ali says, sir, what is a crystalline solid? A crystalline solid is the one in which there are regular arrangement of the constituent particles. Regular arrangement of the constituent particles. That is what we call as a crystalline solid. Safan, you have not attended any of the class of the solid state. Is this the question, Ananya? Okay, explain how much of a question. But it's the 13th number question. Ananya, that's the 12th number. It is 1.12. So, Safan, if you have attended this part, na, how much portion of an atom located at a corner? You need to understand, Ananya, we talked about in the class that the corner atom has 1/8 of the contribution in the unit cell. Okay. So 7 by 8 will be in the neighbors. Okay. So 1 by 8 is in a unit cell. So 7 by 8 is going to be apart from that. And then we talk about the body center. Body center would be 0 because the entire body centered system, the body centered particle is placed within a cube. So body centered particle is not going to be shared by any of the neighbor. Is this clear? And here we have the second part, face-centered and end-centered cells. Ananya, I have already explained the difference between the face-centered and the end centers today itself. Yes, Piyush, that is why I already sent the NCERT. Okay, so that there should not be any difference. Is it clear? 1.19 question from page number 31. You are asking the back questions. This one, Safan? And I am assuring you, Safan, that you didn't attend the class. You didn't. Because if you had attended the class, this was the question we did in the class. We did this question in the class. Ferric oxide crystallizes in a hexagonal close packed array. So we have Fe and we have O. Hexagonal close packed array. Hexagonal close packed array means oxygen has the contribution of 6. Okay. And the octahedral holes are going to be 6, and 2 out of every 3 octahedral holes occupied by the ferric ions. Formula is already here. We have Fe4O6 that simply translates to Fe2O3. Safan, is that clear? Are you reading the NCERT thoroughly? Great. The crystals are very clear now. Anyone has to ask anything here? Any other questions? You clear your doubts, then we are going to talk about the defects in the solids. And we are going to talk about the electrical and the other properties. Okay, Durga Prasad. I was confusing with you with the Ritik Prasad. So, Durga Prasad, any problems with Hindi or English with you? Great. You have to maintain the regularity, beta. If you maintain the regularity, you won't have any confusion in any of the concepts. Hold on, Safan. Let us ask other people also. But till this part, we have done everything. And we have to talk about this imperfections in solids. Whoever has not liked the session, please go ahead and like the session. As far as my PDF is concerned, it is the page number 24. It is the page number 24. Okay, let's talk about the solid state. Now, when we are talking about the imperfection in the solids, when we talk about the imperfections, now let us understand what is the meaning of imperfections. Imperfections. Just remember, we have the arrangement of particles like this. This is the arrangement. I'm making a simple arrangement. I'm not making any arrangement. This is the arrangement of particles that we are supposed to have. Clear? Now, if a particle is present somewhere other than where it should be, let us say it is present here. Now, this becomes a defect. Or it is missing from the position where it should be. Now, this becomes a defect. Clear? It could be both also. And there could be something like this is a line which is going on, and then another line starts from here. Clear? Now, this again is a defect. Okay. Crystalline solids have long range order prerna. Amorphous solids have a short range order. Is that clear? That is the difference between crystalline solids and the amorphous solids. So this is what we have as the imperfections. Is this clear? So we have two kinds of defects. We have the line defects. when the arrangement abruptly ends and new arrangement starts. I'll just give you an example. Let us say I have drawn a line and I stop the line here. Now I want to make another line, and while trying to make another line, I start the line from here. Now, this part will be visible in the crystal. You will be able to see the phase shifting a bit. There will be a difference in the refractive index. It's going to become two phases. You will be able to see in the crystal. If you have seen solid sodium chloride, you will be able to see within sodium chloride that there are crystals which are attached with each other. You will be able to see it. So that is what we have as a line defect. This is a line defect. Royal, I have been in many of the institutes. I was in this institute when you were not even born. Okay. And then we have something like the point defect. Now, what is the definition of a point defect? When a lattice point is missing from the position it should be, or is present at a position it should not be, or both. Okay. Then it's called a point defect. Is this clear? So that is what we term as a point defect. Clear? And yesterday we did a lot of things. So here we talk about the crystalline solids have short range as well as long range order in the arrangement of their constituent particles, yet crystals are not perfect. Okay. Most often the solid consists of an aggregate of large number of smaller crystals. Okay. Now these crystals have defects in them. This happens when crystallized process occurs at a fast or moderate rate. Faster is the crystallization process, more will be the defects in it. Slower the process, lesser will be the defects. Okay? And this is what we have as extremely slow rate. Single crystals, which you can term as the perfect crystals, they are formed when the process takes place extremely slowly. Is that clear? Now, what are defects? These are irregularities in the arrangement of the constituent particles. Now, there are two types of defects. One thing is called point defects, another one is called the line defects. And what they are, point defects are irregularity or deviation from ideal arrangement around a point or an atom in a crystalline substance. I just told you that when the atoms are missing from the position or they are present at a position where they should not be, or both, that is what we call as the point defects. Okay. We are going to talk about only the point defects. The line defects are not in our course. Is this clear? Now, why the naturally formed crystals are better than the crystals formed in the laboratory? Because nature formed crystals are very slow to form. Nature has no problem of one thing, and that is time. For us, time is the most important thing. For nature, time is nothing. Because nature, as far as nature is concerned, it has infinite time. So we are not even the blip on the radar. You may have heard of this particular term, blip on the radar, because radar, when it's moving, if something is there, it's just going to show blip, and then it's going to move further. We humans are not even a blip on the radar of the nature, but we have harmed the nature a lot. But nature is going to cover itself. Nature has no problems with it. The nature is only going to wait for us to go off. How long are we going to exist? Okay. When a lattice point is missing from its position or is present at a position it should not be, it is termed as a point defect. Is it clear? The point defects are classified into three types. Stoichiometric defects, which do not alter the formula. Impurity defects, where we have added some impurities. Now, impurity defect can also be termed as doping. Non-stoichiometric defect, which alter the formula. Okay, so these are the different defects that we have in point defects. Stoichiometric defects are those in which the formula, the cation and anion ratio of the compound does not change. The formula of the compound remains same. These are the point defects that do not disturb the stoichiometric of the solid. There are two kinds of stoichiometric defect. One is called the Schottky and another one is called the Frenkel defect. Now these are the stoichiometric defects. Is it clear? Now these are also called intrinsic or thermodynamic defects. Now they are again of two types: vacancy defects and interstitial defect. Vacancy defect is some of the lattice sites are vacant. Now these are more like in the molecular solids. Simply remove a particular molecule from the lattice and that becomes the vacancy defect. It is going to decrease in the density of the substance since the particles are removable. Okay. Now, Schottky defect also is kind of a vacancy defect, but from the ionic solids. This defect can be created when it is heated, because when it is heated, there are certain particles which might evaporate. They might break apart and evaporate. So this vacancy defect can be created in the covalent solids as well. Okay. Simply particles are missing from the solid. Now this, as you can very well see, all the particles are identical. So this is in the covalent molecular solids. This is what we have as covalent molecular solids. Most often, covalent molecular solids show this kind of a defect. Okay. Then we have interstitial defect. Now, before we get along with the interstitial defect, let me tell you what the interstitial voids are. Interstitial voids. Now, interstitial voids are the voids which should normally be empty in an arrangement. Something like in case of sodium chloride arrangement, the tetrahedral voids are supposed to be empty. In zinc sulfide arrangement, the octahedral voids are supposed to be empty. In calcium fluoride arrangement, the octahedral voids are supposed to be empty. So that is what we have. In an arrangement, the voids which are supposed to be empty are called the interstitial void. Now, the atoms or molecules might be occupying the interstitial voids, and then it becomes the stoichiometric vacancy and interstitial defect. Okay. Now, vacancy and interstitial defect can be shown by non-ionic solids, the covalent molecular solids. Okay. But when we talk about the ionic solids, they show instead of vacancy defect, they have Schottky defect. Instead of interstitial defect, they have Frenkel defect, and there are specific interstitial defect as well. Okay. So again, this is for covalent molecular solids. Is this clear? Here you can see an extra particle is in the interstitial sites, the interstitial positions. Okay, so here we have the Frenkel defect. Now, Frenkel defect is the when ion is missing from its position and is present in an interstitial position, that you have changed the seats. Where you should not be, you should be, you are not there. You are at a different position. So that is what we have as the Frenkel defect. Now, it's a combination of Schottky and interstitial defect. That is, missing is Schottky, interstitial is present. It does not change the formula, it does not change the density, it only is a defect. So that is what we have as the Frenkel defect. The formula and the density remain the same, but the substance becomes an intrinsic semiconductor because now the ions are capable of moving because they get some empty spaces. Now it is shown by the compounds having a large variation in size and of cation and anion, something like, let's say, zinc sulfide. Zinc sulfide is going to show Frenkel defect because zinc and sulfide ions have a large difference in their sizes. Is this clear? So that is what we have as the Frenkel defect. Okay? So it's a combination of the vacancy and interstitial defect. both defects together. Okay. So as you can very well see, the cation is shifted over here and it is missing from here. Is this clear? So this is what we have as the Frankel defect. Clashing Arena, we are doing the deleted syllabus at the moment. Are we not? And today evening also we are going to do a deleted syllabus topic that is called metallurgy. The Frankel defect is also called a dislocation defect. Clear? Examples are zinc sulfide, silver chloride, silver bromide, silver iodide. So that is what we have as the Frankel defect. Then we have Schottky defect. This is basically a vacancy defect in the ionic solids. So equal number of positive and the negative charges are missing. Okay. Equal number of positive and negative charges are missing. Clashing arena beta, first of all, you do the chapters which have not been deleted. Okay. By the time you finish off all those chapters which have not been deleted, I believe, and NTA would be giving you the entire syllabus. Then you can do the deleted chapters. And but this is going to be valid only if you are 12th pass. If you are 12th studying, it will be difficult for you. But please remember, somehow the NTA, they are biased towards the 12th studying people. They are biased towards them. So they are going to give most of the questions from the new NCERT and the syllabus which has not been deleted. So you first of all finish off the syllabus which has not been deleted and wait for NTA to give the notification. ट्रस्ट क्या नहीं है पूछेंगे डिलीटेड सिलेबस हमेशा से पूछते आए हैं ओके नाउ Schottky defect decreases the density. This may be asked from you. Okay. Last time also they had deleted the solid state chapter, but in 2023 they did ask the solid state chapter. Okay, but this is the a big peculiar situation because they have deleted these chapters from NCERT itself. So that makes a bit of dilemma. But we are going to do everything. Okay. Anybody who has kind of doubts whether to study the deleted syllabus or not, whether you talk about new NCERT or old, I would just suggest one little thing. Complete the new NCERT first. Okay. बेटा अक्षय एनटीए को क्या करना चाहिए क्या नहीं करना चाहिए वी आर nobody to say that. The important thing is at this moment every dropper will have to study from the new NCERT and so droppers and the 12 students they have the same kind of positioning. You will have to work very hard. In fact, the people who have dropped they will have to work extra hard because they will have to forget certain things which they know. And that is more difficult than learning new things. Okay, so start with it. Okay, as far as solid state is concerned, this is the latest NCERT of solid state. It is 2022 NCERT that I have shared with you. Okay, the number of these defects in the ionic solid is quite significant. Do you know what is the significant number? It is 1 in 15,000. So out of 15,000 sites, one may be having a Schottky defect. Now this is quite large. As far as a mole is concerned, this becomes a huge defect. And one thing I would like to make very clear to you, no defect will ever make the crystal charged. No defect will ever make the crystal charged. Clear? So you need to understand one thing, the crystal is going to remain neutral. Okay? Oh, I have given it more. It's not 1 in 15,000. It is 1 in 10 raised to power 16. Okay? Now you need to remember this particular example. AGBR shows both Frankel as well as Schottky defect. This question, this example is an important one, and this may be asked in your examination. Now let's talk about the impurity defect. Now impurity defect is also termed as doping, that we have deliberately added some impurity in the solid. We have molten NaCl and it contains little amount of strontium chloride. Now strontium ion is capable of replacing sodium ion, but we need to remember that strontium has a charge of 2 plus. So each strontium replaces 2 Na plus. Charge must be balanced. So one strontium ion replaces 2 sodium ion. Is it clear? Because charge must be balanced. So each Sr2 plus creates one cation vacancy. Each strontium ion creates one cation vacancy. Ayush Gupta, I am not talking about the volume at all. Where did I talk about the volume? I just simply said that whatever position they were occupying, that position is going to become empty. Ayush, where did I talk about the volume being negligible or not? And what difference does it make if the volume is negligible? Tell me the effect. Why you said that volume is negligible? How does it make a difference to me? I never said that the volume is going to decrease. I said mass is going to decrease. So the density decreases. Volume remains the same. Sadia Naz is asking, sir, what is the difference between cation and anion? Sadia, you are insulting me or yourself. Ishika Yadav, you can attend the class right here. What's the problem? Ayush Gupta, I said it will affect the density. What is it? Ishika, it simply means that you had not joined my Telegram group. That is why you didn't have the information about me taking classes on this platform. आयुष, लिखा तो है बेटा कि डेंसिटी चेंज होती है. कुछ भी है ना, कुछ भी पूछ लो, कह दो ये तो बताया ही नहीं था. नहीं, ऑनलाइन में पता है क्या होता है, स्टूडेंट सोचते रहते हैं अच्छा ये क्लास चल जाके ये वाला क्वेश्चन पूछ लेते हैं, पीछे की क्लास का आगे की क्लास का कुछ नहीं पता, बस जाके ये वाला क्वेश्चन पूछ लेते हैं, कोई बात चलता है। ओके, ये लिख लिया आपने डोपिंग के बारे में। ईच स्ट्रॉन्शियम रिप्लेसेस टू सोडियम आयन एंड ईच स्ट्रॉन्शियम क्रिएट्स वन कैटायन वैकेंसी। इज इट ओके? Sadia, I know Hindi, English, both languages, but this session is in English. So I'm teaching in English. Okay? Fine. So as you can very well see, strontium occupies this particular position. Strontium occupies this particular position. It has replaced two sodium, so this becomes empty. But still, the lattice is neutral. Is this clear? So lattice remains neutral. Whatever is the number of cations or anions might be missing from the lattice sites. Okay. Now let's do this question. NaCl is doped with 10 raised to the power minus 3 mole percent SrCl2. Now this question is an extremely important question because it initially came in IIT JEE mains exam. Next year it actually was there in the NEET exam. Next year they introduced it in the NCERT and it was in the board exam. Next year they changed the value from 10 raised to the power minus 3 to 10 raised to the power minus 4 and asked it again. So this is a very important question. It can be asked anytime, anywhere. Clear? Now this question has actually two confusing parts. First of all, it is 10 raised to the power minus 3 mole per cent. That means 10 raised to the power minus 3 mole Sr2 plus per 100 mole of NaCl. Mole per cent. Okay. Clear? So in 100 moles, there are 10 raised to the power minus 3 moles of Sr2 plus. For per mole, it is going to be 10 raised to the power minus 5 mole Sr2 plus per mole of NaCl. Is it clear? Now, I just told you that strontium ion is going to create the number of vacancy as is the number of strontium ion. So, number of vacancies is equal to number of strontium ions. Okay. That's equal to 10 to the power minus 5 mole. But they are not asking you number of moles. You are asking you number of cation vacancies. That's equal to 10 to the minus 5 multiplied by 6.022 into 10 raised to power 23. So that's equal to 6.022 into 10 raised to power 18 vacancies. Any confusions? Ayush, where did you get 2 into 10 raised to power minus 5? Is this clear? Now we are going to talk about the non-stoichiometric defect where the ratio of the cation and anion becomes different from the original compound so that the formula changes. Let's talk about the non-stoichiometric defects. And non-stoichiometric defect are the metal excess defect, metal deficiency defect. Quite obviously, metal excess defect, metal deficiency defect. And to be very clear, whatever be the defects, the formula of the covalent molecular solids does not change because the molecule is the unit and that unit remains intact. We are not breaking apart that unit. Clear? So the formula when it changes is going to be for the ionic solids only. Non-stoichiometric defects are shown only by the ionic solids. Right, Ayush Gupta? It is now 10 raised to the power minus 5 into Avogadro's number. Solve it, you are going to get 6.022 into 10 raised to the power 18. So let's talk about the metal excess defect. Metal excess defect due to anion deficiency. Metal excess due to anion deficiency. Now, the students generally get confused. Even I got confused that what is the meaning of cation excess due to anion deficiency? Either if it is excess, it is excess. If it is less, it is less. What is the meaning of due to anion deficiency? Okay. Let me get a very simple example. Very simple example. Now, we have a particular class. Okay. This class has certain benches here. Each bench is capable of accommodating 2 students. Each bench is capable of accommodating 2 students. Clear? Now, I have 10 students in the class. 10 students in the class. So 10 students, one is going to sit here, another one is 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 here, another here, another here, another here, another here. And this bench is empty. ये कुर्सी खाली है. Now, a person from another class comes to this class and asks the teacher, can I borrow a bench? Can I borrow a bench? Now, the teacher would say, yes, you can borrow. Today, we have excess bench because 2 students are absent. The class does not have excess bench. But since 2 students are absent, that is why the bench may be considered excess. Actually, it is student deficiency. But because of the student deficiency, bench has become excess. Is it clear? Is it clear, Piyush? Is it clear, everybody? Now, here the bench is excess because of the student deficiency, but the room has the capacity of that many benches. Ideally, it is not bench excess, it is student deficiency. In the same manner, if we talk about sodium chloride, it sometimes so happens that certain anions are missing from their position. And those positions of the anion are occupied by electron. System is again neutral. But now we have cation excess because of anions missing from their position. Is it clear? Now that is what we have as the cation excess due to anion deficiency defect, and it is also called the F center defect. Because the position which is occupied by the electron becomes a color center. It creates the color in the non-colored solid. Ayush, we are doing the NEET preparation. Don't go into that detailed mathematics. So I believe it's very, very clear why I said that it is excess due to deficiency. Clear? Even if we have the empty class, we can't say that benches are excess. Benches would be considered excess, which if I have put some bench over the bench, some other place in between the benches, then I would say that benches are excess. Clear? Now here the metal has become excess because of the anion deficiency. And this is what we call as the F center defect. Any doubts? Any confusion in this part? Okay. So this defect is also anion deficiency defect. And there comes, okay, read through it. I believe you have already got this particular notes, so you can just read. Now we get along with the metal excess defect due to the presence of the extra cations at interstitial sites. Now let's take the same example. We have the class, we have the benches, okay, and somehow we have got 14 students. Now we have 14 students. Ayush, we don't need that many details. And is crystallography in your course in physics even? I don't think so. Which course are you talking about? What course are you pursuing? Yes, because of the electron can jump energy states which gives them particular color, right? You are Rajri, Ayush. Now let's say we have 14 students. So what we do is the two students have two other benches in right here. Now remember these are the interstitial position. When the students come in the class, they carry along with them their bags also. When the atoms move into the particular lattice, they bring about their electron also. The electrons occupy certain other interstitial positions. Now, these are interstitial electrons, and they also make it colored. Okay? And this happens with zinc oxide. If you heat zinc oxide, then in that case, it is supposed to be a white substance, but you heat it strongly, it becomes yellow. So zinc oxide becomes yellow when it is heated strongly. Okay. Now, why this happens? We have the oxide lattice. If you heat it, oxide is released out in the form of oxygen. So zinc oxide, when heated, gives Zn2 plus 2 electrons plus half O2. This half O2 escapes. These two move to the interstitial position. Is it clear? And this gives yellow color. Any confusions, anybody? The F-center defects, they cause a decrease in density from the ideal. This particular cation excess defect, it causes an increase in density. So can you understand these two are different defects? Akshay has joined the course. Akshay, I have given you the access and I have given the access to Chandan Kumar as well. Can cations move? Yes, cations can move either by heating or they can move by putting the electrical uh, potential. Any confusions here? AK Gaming. Hello, beta. Like the session first. Now we have metal deficiency defect. Metal deficiency defect can be created by two way. One way, in fact, that is by replacing some lower valent cation by a higher valent cation. Something like we created by impurity. That is, we put strontium ions in sodium chloride. That can be done even by the same substance, like Fe3 plus replacing Fe2 plus. So it is because of the cations being replaced by higher valency cations. Okay, like Fe2 plus by Fe3 plus. 3 Fe2 plus are equivalent to 2 Fe3 plus. So, one vacancy created. Is it clear? Fe2 plus are missing, Fe3 plus replaces it. Each three Fe2 plus are being replaced by two Fe3 plus. So one vacancy is created for every three Fe2 plus. Is this clear? We have done this already. Can you solve this question? Can you solve this question? I do have a method of solving it, but you might have another method of solving it. Solve it. Now, for a very long time, this question was considered a very difficult question. Many of the teachers were not able to solve it. A very small trick is there. Very, very small thing. What you do is you write it Fe3 plus, you write it Fe2 plus, you write it O. Let Fe3 plus be x, Fe2 plus is going to be 0.9 minus x, and O is 1. The charge of 3x Fe3 plus would be 3x. Here it is going to be 2 into 0.9 minus x. Here this is going to be minus 2. Now the total is going to be 0. Can you find the value of x now? If you find the value of x, you will be able to find what is the ratio. Go ahead and do it. Thank you, Sadia. But my teaching is going to be appropriate only when you attempt the questions. Go ahead and attempt the questions. Yes, x is equal to 0.2, that means Fe2, Fe3 plus, that becomes 0.2, Fe2 plus becomes 0.9 minus 0.2, that is equal to 0.7. Ratio of Fe3 plus to Fe2 plus is going to become, ratio of Fe3 plus to Fe2 plus is going to become 0.2 is to 0.7. That simply means 2 is to 7. Why can't you solve it, Sadia? A simple linear equation is written here. The equation is written right in front of you. You went for the breakfast, so what? I gave the equation later. And Sadia, you have not joined my website. Go ahead and join the website. And please remember, the people who have joined the website, they have to attempt the questions. I'm going to upload the questions of each and every topic that we have already done, and they have already been uploaded. So you can attempt as many questions as you want, and we can upload the tests also. If the percentage was there, what's the problem? Percentage is simply 2 by 9, 7 into 100. That will become the percentage. What's the big deal in it? And Chandan, Tirthraj, Ritik Prasad, Prerna Rajput, Ananya Sarkar, Akshay Thakur, Arshna Verma, Dr. Vivek, you have not attempted the questions from 11th class. Oh, you have not attempted the full syllabus test. I believe you have attempted the 11th class or not. Oh, it should be 2 by 9. Thank you, Ayush. It'll be 2 by 9. Total is 9. 2 by 9 into 100. Ratio is 2 is to 7. Is this clear? Solve this question. This is from NCERT. Solve it. Whenever I ask a question, people rush away. Where are you? This is Ni 3 plus x, Ni 2 plus 0.98 minus x. Oh, so it's going to be 3x plus 2 into 0.98 minus x minus 2 equal to 0. Can you get the value of x? I believe the x value turns out to be 0.04. So the ratio is 0.04 is to 0.94. That turns out to be 0.02 is to 0.47 or 2 is to 47. Any confusions, anybody? Now, this is a very important, because all the calculations that we are doing are based on this particular fact. Clear? So we have just talked about these defects. Frankel defect is also called a dislocation defect. Remember this name? Because they can ask you which of these is a dislocation defect. अच्छे से पढ़ाइए थोड़ा सर, थोड़ा सा फास्ट, थोड़ा फास्ट जाने के लिए कह रहे हो शगुन? You are not even solving the question, Shagun. How can I go fast? For me to go fast, you have to solve the questions and give me the answers fast. We have done these examples. Impurity defects we talked about. We talked about the non-stoichiometric defect. We talked about the metal excess defect. Here. Now we have the electrical properties of the solids. Okay. When you talk about the electrical properties of the solids, we have conductors. Their conductivities are ranging between 10 raised to power 4 to 10 raised to power 7 ohm meter inverse. You can even call them 10 raised to power 4 to 10 raised to power 7 Siemens meter inverse. Fine. Or their resistance could be from 10 raised to power minus 4 to 10 raised to power minus 7 ohm meter. Shagun Yadav, beta, I have very few students, as you can very well see. Okay. So maybe these are the students who are matching frequency with me. Clear? Majority of the students, their frequency matches with the other teachers, but there are very few whose frequency match with me. So let me teach those students. Okay. If your frequency is not matching with me, you are absolutely free to go to any other person, isn't it? Nobody can stop you here. क्यों नहीं दे पाए बेटा प्रेरणा? Okay, fine, no problems, Prerna. You were able to do the questions. Don't worry, we are going to give you many options to solve it. And Prerna, I have already given you the questions on the website. Why don't you attempt the questions there? There are so many questions on that website. Okay, you can practice the questions right there. And we are very soon, maybe today itself, I'm going to upload the tests of the various chapters that we have already done. Okay, so this is what we have as insulators, that is what we have as semiconductors, that is what we have as the ranges. Clear? Now here we have the conduction band and the valence band, intrinsic and extrinsic semiconductors. This is what we have as band theory of electrical conductance. क्यों नहीं हो रहा प्रेरणा? ओपन हो जाएगा. You can even download the app. Prerna, you have logged in 2 days, 13 hours ago. Okay, I have only 7 students watching at this moment. Okay, we have metals, insulators, semiconductors. The topmost is the conduction band, the lower one is the valence band. The electron can move from the conduction band to the valence band and show conduction. And the valence band is going to have vacancies and it moves. Now, this is what we have as the creation of the N-type or P-type semiconductor. Please remember one again thing. N-type, P-type, they are neutral. None of them is charged. Remember that. Read through it. It should be making very clear. It should be very clear to you. Remember them. These are asked. Now, they are very important. They are asked. जो मर्जी करो बेटा, प्रैक्टिस करना जरूरी है. Okay. You can initiate with the questions from the exemplar. Exemplar questions have been uploaded there. है ना? Start with the exemplar questions. Each and every chapter exemplar questions have been uploaded. There are so many questions out there. हाँ, बहुत सारे पेपर्स हैं. Magnets produce magnetic field. Yes, magnets have the magnetic field around them. Talking about paramagnetism, species which have one or more unpaired electron. The species which have one or more unpaired electron. Ananya, the name is not Sandhya, it is Sadia. Okay. So these are the paramagnetic substances which contain unpaired electron. Diamagnetic is when all electrons are paired. When all the electrons are paired, it becomes the diamagnetic substance. Now, ferro, ferri, and antiferro, they are paramagnetic substances. Okay, clear? Any confusions in these? Yes, ferromagnetic substances and ferrimagnetic substances are attracted by the magnetic field. Ferromagnetic are attracted very strongly, ferrimagnetic are attracted weakly. Examples, remember these examples. These examples make the questions very difficult. Here you can get a for molecular solids. When you talk about ionic solids, then in that case, it could be the cation excess defect which could be created. Ha, Akshay, if magnets are heated to a very higher temperature, then they lose their magnetic properties. Then the answer is very simple. The kernels, the domains, they randomize. Because of the domains getting randomized, a different definition. Well, Sadia, your name is Sadia. If you ask anybody, you are going to get the name same as Sadia. You don't want the name to be changed to Sandhya. Cations are positively charged. They move towards the cathode. They are created at the anode. That is what the cations are. And anions are negatively charged atoms or negatively charged ions. They move towards the anode and they are created at the cathode. Is that clear? So that is what we have as cation and anions. How are you going to get a different definition? And I fail to understand Sadia Naz. What is the meaning of from this teacher? Sir, one. Okay. Now you can attempt the questions of solid state. Anyone has any kind of doubts anywhere? Remember at 4 p.m. we are going to start with the metallurgy and hopefully finish it. Is that okay? So whoever has not liked the session as yet, go ahead and like it. We have finished off with the solid state chapter. Read through the NCERT, attempt the questions. Okay? Bye bye. We'll meet at 4 p.m. Sadia Naz, what explanation do you need? Call me. Call me on this number. Okay? I'll answer you. Call me right now. Swati, I'm waiting for your call. Bye bye. Hope to meet you all at 4 p.m. on the session with metallurgy. Bye bye. Take care. And just to talk about here. Hmm? That's Shubham Mishra. Hello. Okay. So this is what we have as iconic mega sale week, which is going on. And this is what we have. You have 2 p.m. botany, 3 p.m. you have zoology, and 4 p.m. again you have chemistry. So be there and join our Telegram channel for UQ classes PDF, t.me/neat elixir. Join with us. Join this particular website. Subscribe to NEET Elixir by Unacademy for the best live classes. Bye bye. Meet you at 4 p.m.